So, AQA level chemistry paper 1, Tuesday, 2nd of June 2020, question 1. Born-Haber cycle, and it doesn't want us to complete the table, it wants us to calculate value for electron affinity of chlorine. So we know that the enthalpy of atomization of chlorine plus 1 to 1. So this bit is plus 1 to 1. Enthalpy of atomization of strontium plus 164 plus 164. First ionization energy of strontium 548 plus 548 quick thingy, because we have two chlorines, enthalpy of atomization of chlorine is going to be 1 to 1 times by 2, something I just spotted now. But now we can carry on. Second ionization energy of strontium plus 1060 enthalpy of the lack of formation of strontium chloride so minus 828, and what we're trying to find is electron affinity of chlorine. We're trying to find this value. So what we can now do is couple the values together. So we can say minus 828 is equal to the rest of them. Enthalpy of formation is equal to the rest. So we can get minus 828 is equal to the enthalpy of formation is equal to 164 plus 121 times by 2 plus 548 plus 1060 plus x, right? Well, no, because this electron affinity of chlorine, so it's going to be times by 2 because there's 2 chlorine, so it's going to be 2x. That's obviously going to be 2x, so plus 1060 plus 2x minus 112. So we get 2x equals 164 plus 121 times by 2 plus 548 plus 1060 minus 112 plus 9, and then we can do minus 828 plus that, and then divide by 2. I think I put too many values in my calculator. Yeah, I keep getting. So it's going to be 164 plus 2 times by 121, 406. 406 plus 548 plus 1060 minus 2112. So we get minus 828 28 equals 2x minus 98. Oh, that's why I made a mistake. I did minus 98, we add 98. 2x equals minus 730. Therefore, the electron affinity of chlorine is minus 365 kilojoules per mole to the power minus 1. Then it says draw a line from each substance to the enthalpy of lattice formation of that substance. So we've got magnesium chloride, magnesium oxide, and barium chloride. Well, barium chloride is going to be minus 2018. Magnesium oxide is going to be this one, minus 3888, minus 3889. And magnesium chloride is going to be minus 2493. However, it's only one marker, so if you don't get it, it's taking too long in it, just skip it. It's just one mark for 3 lines. 1.3. State why there is a difference between the theoretical and experimental value. Well, this one's pretty nice. It's got covalent character. It has covalent character. So therefore it's going to be a difference. 1.4. Table 3 shows enthalpy of hydration values for ions. Also, group 1 elements. Explain why the enthalpy of hydration becomes less consistent from Li plus to K plus. Well, we know from Li plus to K plus, the size of ion increases. Hence, electrostatic attraction between metal, iron, and oxygen are partially negative of water decreases. Size of iron increases, electrostatic attraction between oxygen partially negative and oxygen partially negative, water decreases between metal, iron, and that. And then it says 1.5, calculate enthalpy of hydration. So if you think about it, we are going from, what is the thingy? We're going from calcium bromide to it dissolving in water, so CaBr solid arrow Ca plus aqueous plus Br minus aqueous, and we've got Ca in gas plus Br in gas in the bottom. Arrows pointing upwards, and we know the enthalpy of solution of calcium bromide, enthalpy of lattice formation of calcium bromide. So to form calcium bromide is minus 216, minus 2176. That's for the arrow to be this way. We know the entropy of solution of calcium bromide is minus 110. Actually, will that even... Let's remove all and let's try this question again. So we've got, it's CaBr2 solid. So everything I said would even matter because we've got 2 bromine ions. So calcium bromide, I should have known that, to form 2 plus aqueous plus 2 Br minus aqueous. And then, yep, we've got in this gaseous state at the bottom, the cycle arrows are pointing upwards, and we know to go from calcium bromide to here is minus 110. We also know the entropy of formation of calcium bromide, so this arrow here is minus 2176, and we also know entropy of hydration of calcium ions, this arrow, minus 1650. This one's pretty easy. We're adding water, gas to aqueous, so just arrow point upwards. And then for the 2Br minus, what are we gonna do? Well, that's what we're trying to find. Yeah, that's what we're trying to find. So it's just going to be 2x, so 2 times Br. So we'll just say 2x. So now we can basically construct an equation. So minus 110 is equal to, from here to here, what's it called? The state has a law. The total entropy change is independent of the route taken. So to get from here to here, it's the same as going here, from here to here, and then from here to here. So that's exactly what we're going to do. Minus 110 is equal to minus 2176 plus minus 1650 plus 2x. Well, this can become a positive. So we get minus 110 is equal to 2176 minus 1650, 526 plus 2x. Minus 110 minus 526 minus 110 minus 526 divided by 2, and we get minus 318 kilojoules per mole to the power minus 1. So the tricky part with this question is, well, I should have known it's CaBr2, and then the rest of it is pretty simple. Just need to practice it a lot of times, and then you'll be able to identify if it hasn't given you it's giving you a table of data. It wants you to find out entropy of hydration, entropy of something. I'm going to use a cycle, especially when it's more than 2 marks. So if it's 1 or 2 marks, you probably use it in an equation, but if it's more, you're generally using a cycle. And that is the end of question 1.